thank you, Simon. And absolutely, Cure Parkinson's has been involved in this from day one. When Richard, wherever Richard's gone, came to my office and talked about, if we're in a position to try and find out if exenatide was of any use or not. So, my name is Tom Foltynie. I'm a neurologist. I work at the National Hospital for Neurology and Neurosurgery. It's a hospital about a mile away from here, a bit under. And it has the patient services, and on the same site it's UCL neuroscience essentially. So it's very good at being an interface between providing a service but also providing research opportunities, in the whole pipeline from basic science to clinical trials. So I've been involved in looking at this drug exenatide for quite a number of years. So as Simon said, exenatide is a licensed treatment for type 2 diabetes. It works on the GLP-1 receptor. So before I lose everybody, just to tell you that when you eat something, the cells in your gut produce GLP-1, and that acts on cells in your pancreas and to release insulin, and that keeps your blood sugar under control, stops you getting very high levels of sugar every time you eat a meal. And GLP-1 disappears within a few minutes. But there are GLP-1 receptors all around the body, including in the brain. And there's been a lot of interest in what happens if you stimulate these GLP-1 receptors, outside this control of blood sugar. Now, because GLP-1 only disappears within a few minutes, drugs like exenatide that stimulates the GLP-1 receptor and continues to do so for many hours has been an area of interest, not just for brain doctors like me, but for heart doctors and for liver doctors. And see, these GLP-1 receptors might be of major interest in body health in multiple specialties. So, having done 2 trials previously, we set up this phase 3 trial looking to see if exenatide might help in patients with Parkinson's disease. This was a double-blind, placebo-controlled trial, and we were looking for disease-modifying effects. So apologies to anybody who was in the trial who came to a meeting where we disclosed the results earlier. So I'm going to go over the same data once again today. So as I say, this was a multi-center trial. We wanted to compare exenatide against placebo. It comes as a once-weekly injection, so people had to inject themselves under the skin once a week with a disposable pen, and then the next week do the same again. So people on placebo were using pens that had a dummy form of exenatide. People on the active drug were doing exactly the same. So we recruited people with very broad inclusion criteria from the age of 25 all the way up to the age of 80. But they had to be relatively good enough to be able to attend, so that they couldn't have bad balance right at the start. This is the Hearn and Yale staging, lesson 2.5. In terms of the primary outcome, which was a question earlier, we use the UPDRS Part 3 motor score, which is the clinician's rating of how good or bad you are, based on finger taps, hand flashes, arm movements, walking, balance, speech, etc., which is a clinician's view on how bad Parkinson's is from a motor perspective. Even if that doesn't mirror what a patient may feel, it's the score we chose. And we were looking to see how that changed when someone deprived themselves of levodopa overnight, starting at baseline and over the course of 96 weeks, which is approximately 2 years. And so we recruited 200 people, and they were randomly allocated to either have the active drug or placebo. So doing the randomization is a way of improving the quality of the science, that the patients, if you have a large enough group, random allocation means they should be matched in terms of what would have happened had you not intervened. And we do an analysis by something called intention to treat. So if we randomize people into 2 groups and then follow them up, the randomization is a critical thing. If someone drops out, then we still include them in the analysis. And that's the most scientific, robust way of looking to see if a drug is effective or not. So in terms of the outcome, as I said, we did the UPDRS Part 3 off medication first thing in the morning. That was where we put all of our money, that this would be the thing that would hopefully change. We looked at other aspects of the UPDRS. So Part 1 is non-motor symptoms, Part 2 is activities of daily living, and Part 4 is the complications of drug treatment, so dyskinesias and fluctuations. We had the formal dyskinesia rating scale, did the non-motor symptom scale. We looked at cognition with something called the MOCA, depression with the PHQ-9, quality of life, and some health economic data. We also measured the speed of walking. We calculated how much levodopa and dopamine agonist people were on, and we measured their weight. And we also tried to get slightly more objective data, as I mentioned earlier, using these digital measures that Cameron may have spoken about it during the break with his poster. So we had two measures. One was the Oxford smartphone. So, 3 times a day for a week, people would be asked to measure their tremor and then tap on the phone and see how quick they were with one hand or the other hand, put the phone in the pocket, walk up and down, and it would capture some information objectively 3 times a day for a week, and then that could be compared every 6 months to see how it was changing. And the activity lumbar sensor is a little sensor that you can put on your back, just attached with a little sticky, and people would wear that for a whole week, even in the bath or the shower, overnight, and that would record how much movement, how many steps they took, and again, a measure of activity and what changed over time. We did DAT scan imaging in a percentage of people that came to our centre at Queen Square. We did lumbar punctures at the start and at the end in a subgroup of people who came to Queen Square, and people were hugely compliant with agreeing to have lumbar punctures. And I'd reassure people that this is a pretty painless, completely safe intervention that's hugely helpful in trial research. And of course, we did blood tests. We took blood for DNA so we could look at people's genes. And we also, in a subgroup of people, got them to attach a little wire to their thumb and first finger. So when they're doing that, as our measure of how quick their finger taps are, we could actually get a very highly sensitive computer score rather than just someone saying, yeah, that's good, bad, or not very. So we planned to open the trial in October 2019, but we had a couple of months delay in terms of the drug and placebo being delivered. So we were a few months late, and we opened in January 2020, and we promptly recruited 8 people. And then Boris Johnson said, nobody's allowed to go out anymore. And so our clinical trials unit said, well, you can't recruit any more patients. This was a major crisis for research, not just in the UK, but globally. We managed to maintain our first 8 people within the trial, which was a major achievement, rather than just starting again sometime later. And then as soon as we were able to, so in the summer of 2020, we reopened to recruitment, and recruitment matched what we were hoping for. We had another lockdown at Christmas that year, and then we reopened, and we had to finish recruitment 6 patients short of our total. And that was because, the drug had a shelf life. And 2 years after that time point, when we had to finish the trial, the drug was going to expire. So had we not had the pandemic, we would have been fine. But because of the pandemic, we were 6 patients short. So this is what we call a consort diagram. This is the flow of patients. So we pre-screened people. So we had very broad inclusion criteria anyway, but we pre-screened who we thought was likely to be eligible, and we looked at 215 people. Some were ineligible for various reasons, being too skinny or having other problems as well. 194 were randomized. Ideally, this would have been 200, but as I said, we're 6 people short. So they were assigned randomly to either have exenatide or placebo. We had a few people withdraw before the first 6-month visit. And it's this 6-month visit where we first captured data to see what had changed over time. So everybody that got to that visit was included in our formal analysis. Even if we had a few dropouts over the next 18 months, it didn't matter if you dropped out at this time point, you were included in our formal analysis. So we had 8.2% of people drop out overall, 12 of whom were in the exenatide group, 4 in the placebo. And so overall, the discontinuation rate, this is stopping the drug, even if we carried on following up, there was a 15.5% withdrawal, so 23 exenatide, 7 placebo. So rather than excluding people because they stopped the injections, we carried on following them up and they contributed to the data. So this is what people were like. The age, this is the exenatide group, this is the placebo group, and this is the overall. So you can see that they were just over 60 years old, having had Parkinson's disease for about 4 years. This is how tall they were, and this is how much they weighed. It's slightly heavier than I was expecting. I sort of envisaged most people with Parkinson's being a little bit on the slim side, and we were all worried because one of the side effects of exenatide is weight loss. But most people had a couple of kilograms to spare, which was good. So at the start, they measured, they had 32 points, so the higher the number, the worse the severity. So on this Part 3 scale, 32 points, so almost identical between exenatide and placebo. This is their non-motor symptoms, so 7 points on that scale, 7 points on the activities of daily living. And you can see that the off scores improve from 32 to 20 when they have their dopaminergic medication. So most people are responsive to levodopa. And this is their body mass index, which is you calculate from looking at their height and their weight. So this is a healthy body mass index. This is how much levodopa equivalent they were on, so about 475 milligrams. This is their UPDRS Part 4, so motor complications. EQ5D is this measure of to try and extrapolate how people are disabled compared with other diseases. Non-motor symptoms, dyskinesia. So you can see essentially the randomization in this number of people gave us pretty perfectly balanced groups. So there was no difference between the groups at the start as a result of the randomization. 28 females, 69 males in both groups. So this is disproportionate, and there is a slight excess prevalence of Parkinson's disease in men, but not to this level. So, diversity includes gender, includes age, includes geography, as well as ethnicity that we'll think about. And so we need to be slightly better at recruiting more women to trials because this is an under-ascertainment of women. In terms of ethnicity, the vast majority, so 92 out of 97 were white, 88 out of 97 placebo. So we asked people to record their ethnicity, and we had underrepresentation of pretty much all ethnic groups. And we've been doing a lot of work to try and explore the reasons for that and the ways of trying to overcome that in our subsequent trials. So this is looking at the raw data. And it's impossible to glean anything from this. But the reason for showing you this is you can see at the start, there's a large range of scores on this. The mean was 32. But within that 32, some people are right down here, other people are right up here. And then the progression over the 6, 12, 18, 24 months, or 96 weeks, is all over the place. And this is in the exenatide group, and this is in the placebo group. So from looking at all of this individual data, it's impossible to say, well, did the drug do anything or not? It's only when you look at the mean, and you do statistics on the mean, that you can interpret this. This is the result. So this is the score at the start, and the blue line is patients on placebo, the red line is patients on exenatide. You can see we've got a few dropouts, but this is pretty well powered to capture what has happened as a mean. There was no advantage in patients on exenatide compared to placebo. So we do statistics on this. So this is coefficients. We use mixed effects modeling. So you don't need to trouble yourselves too much about what mixed effects modeling means, but it takes into account what the difference in severity at baseline was and what the trajectory you might expect. If we had a negative number, that would favour exenatide, but this is just slightly positive. And if we had a p-value of less than 0.05, this would be statistically significant. So neither is this favouring exenatide, nor is it significant. We did something called a modified intention to treat analysis, and this is excluding some people who dropped out within the first 12 weeks. Again, this doesn't make any difference. And so this is what we will report as the key result from the trial, that there was no advantage of using exenatide on our primary outcome measure, which is this OFF score. So I'll just pause there. That is the key message of the talk. Disappointingly, we did not get an advantage of using this drug on our primary outcome. These are I suppose, some of the important secondary outcomes. So this is the Part 1 non-motor symptom scale, Part 2 activity of daily living, Part 3 on dopaminergic replacement, and Part 4 motor complications. In all of these vertical lines are the confidence intervals, and they're completely overlapping. There's no statistically significant difference between the exenatide and the placebo groups, which, as I say, is very disappointing and to some extent very surprising. We also found no difference on the MOCA, which is the cognitive scale, dyskinesias, non-motor symptoms, quality of life, EQ5D, or depression. In terms of timed walks, essentially at the midpoint, 48 weeks, there had been no change in either group. And at the 96 weeks, there was basically a 1 second difference in the time taken to walk 10 meters in both the off state and in the on state. The levodopa equivalent dose, people were allowed to change their medication. That changed 100 milligrams in both groups. There was 2 kilograms weight loss in the exenatide group, which essentially stayed the same in the second year. The placebo group lost 300 grams in the first year. They lost 1 kilogram in the second year, which is interesting. And we can talk and speculate about, the reasons why people may have lost weight in the placebo group. So just to highlight that we expect exenatide to cause weight loss. It did cause weight loss, and this degree of weight loss is about 2 kilograms, which is similar to what's seen in patients with diabetes who are treated with exenatide. So that in terms of target engagement that you'd expect, this was pretty similar. Of course, as part of a trial, one of the most important things is looking at the safety and tolerability. We heard from Bina that's their primary outcome. And so we capture every detail of what happens to people during the course of their trial. And that the list is actually very, very long indeed. We've had to, talk about other categories to make this easier to interpret. But anything from having dizzy spells, bloating, insomnia, anxiety, having a upper respiratory tract infection or COVID or urinary tract infection, all of these things are captured. The thing to highlight is that there's no difference in terms of having a reaction to the exenatide. So people got nodules under the skin, and that was the same with the active drug and the placebo. So that didn't give the game away, who was on the active drug and who was placebo. There was an increase in the serum amylase level in 9 people on exenatide, which is a slight fear about exenatide. Does it upset your pancreas to some extent? And that stayed with the exenatide since it was first launched for diabetes many years ago. We didn't have any clinical cases of pancreatitis, so no one had a worrying effect. But whenever we saw this, we told people to stop the injections for a couple of weeks, and let that number come down, and then they restarted. So that's again is demonstration that the people on exenatide were experiencing side effects such as weight loss, such as GI upset, such as bloating that we expect with these drugs. The next thing we went on to look at is, well, hang on, what about in the people that were absolutely stuck to using the injections once a week, every week for the whole of the 2 years? So we did something called a treatment adherence analysis. So people who are 80% compliant, so use at least 80% of their injections. So 74 exenatide randomized patients were 80% compliant, 91 placebo patients. But again, there's no significant advantage in that group. And if you tighten it even further, only those who are 90% compliant, of course, the numbers get a little bit smaller, but again, no advantage seen. So even in those people who were meticulous and religiously took their exenatide, this did not confer a benefit, which again is very disappointing. So this is the summary slide. It did not help the primary outcome. It did not help the secondary outcomes. It was safe, it was well tolerated, despite all those adverse events I showed you. Generally, people continued with the drug and were happy to stay on it. Many of the adverse events were part of the known side effect profile. We did see these transient elevations in amylase, and that is an ongoing concern about the drug. But in conclusion, and this is what we have to report, that this dose of exenatide, given weekly over 2 years, does not change the rate of progression of a broad population of Parkinson's patients. And that's who we recruited, a broad population. So firstly, we can be confident that these results are accurate and correct. This trial was sponsored by UCL's Comprehensive Clinical Trials Unit, so the regulations and the attention to detail, the standards that people have to adhere to are incredibly high, so we can be very confident that these data are accurate and correct. Patient retention was very high, so we're, of course, hugely grateful to all the participants for sticking with the trial and for all the centres for being motivated to retain patients within the trial. As far as possible, we asked that the same people who rated the severity of Parkinson's disease on day 1 were still rating patients for the whole 2 years, so there wasn't noise introduced by different raters at different time points. And we made sure that the people who were rating Parkinson's severity weren't told about side effects such as amylases or weight loss. The fact that we didn't hit our primary outcome is also mirrored by we didn't hit any of the secondary outcomes either. So there's consistency across the different outcomes, which in a sense is easier to interpret. If we had some things which favored exenatide, some things favored placebo, then there's uncertainty. But this is consistent across all of the different measures we use, and therefore I think we can be completely confident that the results are accurate. And we have to be sanguine about this. This is an experiment. The results are the results. It's extremely disappointing, but there's no point saying, well, it's wrong. These are the data. So the question that we've been asked, that I've been agonizing with, that lots of people have shared because they've also been surprised about this, is, well, how come this is negative when you published a paper in 2017 that the exenatide was helpful? And so what's the difference? And so we've looked to try and work this out. So the age and the gender distribution of people in this trial is almost identical to the people in the last trial. So there's no obvious difference in how we've recruited people. They had very similar disease severity when we saw them at the start, 32 points in the off-medication state. There was a slight difference in the disease duration. So last time, the mean disease duration was 6 years, this time it's 4 years. So I'm going to come back to that because we've looked at that again. The patients were on a slightly lower dose, 475 milligrams this time versus 774 milligrams last time, so that they had longer duration, used more dopamine replacement. And in the last trial, there was a slightly greater weight loss. I've highlighted this time it's just under 2 kilograms. Last time it was 2.5 kilograms. And the placebo group didn't lose very much weight at all. So the question that people say is, well, surely there's a subgroup. There's a subgroup somewhere that respond to this. You just need to find it. We looked at Hearn and Yahr stage. It is Hearn and Yahr 1 and 2, the more milder. 2.5 is where they have balance problems. This coefficient remains positive, which means that we don't favour exenatide. P-value is non-significant. We looked at under 60s versus over 60s, and this is important because in the recent lixazenatide trial, and possibly in the Neurally trial, there might have been an advantage in the under 60s group that wasn't seen in the over 60s. However, in our trial data, there is no advantage in either younger or older groups, nor if you define age of diagnosis. Again, there's a hint, or perhaps we know that this negative coefficient, maybe this exenatide is better in women, but the confidence interval includes 0, so there's no. This is not evidence. This is consistent with no effect, and the p-value is again not significant. What I wondered is, have we done this really well at Queen Square, but every other site has made a mess of it, and this, and this was my reaction. Like, oh. I've trusted my colleagues around the country and they've made a pig's ear of it. However, Christine and Nero, who did a fantastic job at Queen Square in terms of the quality of the data, in that group alone, there was no advantage in exenatide. And that has convinced me, well, okay, if it didn't work in our hands at Queen Square, it's because it doesn't work. And the data in the other sites are based on far smaller numbers of patients. So back to the last trial, including people with a mean duration of 6 years. So, I thought, well, better look at that. Does it help in people that have longer disease duration? The answer is no. It's not that we've recruited people earlier. This question about weight loss, has there been no difference because our placebo group have all joined the gym and they've started losing weight, and that's why there's no difference between the two? This is looking at correlation coefficients between degree of weight loss and degree of UPDRS change, and there is absolutely no significant correlation or sizable correlation between weight loss and clinical change. So it's nothing to do with just losing weight, ruined our chances of finding a positive effect. You may have heard of a recent test where you can detect the pathology of Parkinson's, this alpha-synuclein aggregation. This is the protein which is thought to be implicated in the cause of Parkinson's disease. You can do a lumbar puncture and you can test for this seed amplification assay and say, well, this person definitely has the alpha-synuclein process and this person definitely doesn't. So because we had lumbar puncture data, these CSF samples, we tested our 66 samples that we had, and 63 of them were positive for this. So, which is about what you'd expect. So about 95% of patients who are recruited with Parkinson's disease are positive for the seed amplification assay. It doesn't mean that the other 3 don't have Parkinson's. It just means that they're negative for this. And there's a lot of debate about how to interpret that. So, the patients that we recruited were the patients we were trying to recruit. Basically, they had this alpha-synuclein seed amplification assay. The next thing I worried about is, well, hang on, what if AstraZeneca just sent us a bunch of dud drug? They sent us good stuff last time and it worked, and now it's just been the stuff that's been on the bottom shelf because they don't really care anymore. And so we immediately sent our plasma samples to a colleague in the States who could measure the exenatide levels, and we found that the level in this trial compared with the level in the last trial, and we sent the samples from the last trial as well, so they could be compared contemporaneously, there was no difference. So the AstraZeneca, of course they did. They sent us the normal product, the same quality, no difference. We also checked, some of our placebo group to make sure that they didn't have exenatide in their plasma, just to be certain that our randomization had worked and people hadn't gone out shopping and bought themselves exenatide and that. So again, it was not detected. So we know definitively that those exposed to the drug had the drug, those exposed to placebo did not have the drug. So I'm trying to be absolutely definitive about this and leave nobody in any doubt that in this population of patients, the drug did not work. This is clear, this is definitive, it does not change the rate of progression in this population. So what does this mean? So this has got to be in the context of a lot of work that led to us doing the trial in the first place. So in the laboratory, the rats and the mice, exposed to toxins or alpha-synuclein preformed fibrils or transgenic, animal model that you can come up with for Parkinson's disease, in all of those poor rats and mice, exenatide is brilliant. It works really, really well. And if you've got diabetes, and so you've got an increased risk of Parkinson's, if you have diabetes and you get given exenatide, your risk of Parkinson's diminishes. So, why can all of that be true, and yet when we give it to patients in Parkinson's disease, it doesn't appear to make any difference? So, what does this mean? I'm also going to discuss this issue that lots of trial participants have said to me, well, hang on, I don't really care if it didn't help the whole population. It helped me, and therefore I want to keep going on this drug. And this is an example. This is someone who was recruited in Oxford. At the start of the trial, this UPDRS Part 3 score, 43, so a bit higher than average, got a little bit worse in the first 6 months, but then this worsening improved over the rest of the 2 years. And so to them, they're better than they were at the start, and it's been a gradual improvement. That's quite, you can understand why this person thinks, the drug worked for me. I'd like to, ignore the rest of your trial data and focus on what matters for me. This is a Queen Square participant on placebo. Bang in the middle at the start, got better, got even better, stayed better. On placebo, no exenatide detected in blood or spinal fluid. So there's, this person did not get better because of the exenatide. And so what do I say to this Oxford person, bearing in mind that exactly the same can happen on placebo? It's been really an anxiety that we've put too much emphasis on this UPDRS Part 3, and the question earlier about, well, your outcome measures are rubbish, you need to do better is entirely valid. So Cameron, his poster is on activity and looking at how people moved over the course of a whole week at baseline, 6 monthly until the end. There was no advantage in people that use exenatide compared to people using placebo. And Michelle Hugh and her team in Oxford have been looking at the smartphone data. And again, rather than stealing their thunder, I'll just say, there's not going to be any positive news from that either. So back to this, exenatide worked for me. I did wonder, can I tease out those people who had a really annoying placebo response from those who had a proper exenatide response, and there's a difference, and if only I can work out, how to categorize these people, I can get the answer. And so I just made up these rules. Some people had no response, and for them, I defined it as, did they get worse by 5 points over the 2 years? And if that's the case, then they're not a responder. And some people had a definite placebo response. They got better in the first 6 months, and then in the last 18 months, they deteriorated. And that's just, enthusiasm early on, and of course, reality kicks in for the last 18 months. But the proper exenatide response will be, well, they didn't get worse over 24 months. And that failure, that lack of getting worse continued even in that last 18 months. And that would be a more realistic, expected effect if the drug was really going to be helpful. And so I just made up these, can I try and distinguish the placebo effect from a real effect? So those people on exenatide, we had 24 non-responders, 17 who had a placebo-type response, and a 43, which I thought was more like a disease-modifying response. People on placebo, very similar non-response, slightly more placebo responses, but just as many that had this similar, flat line in the last 18 months. So even if you try and say, well, we can tell what's a placebo response and what's a real response, there's nothing concrete in this. The most important question in my mind that is still unanswered is, did the drug fail because it didn't get to its target? Now, in the last trial, we measured exenatide in the serum, and we measured it in the CSF. So 543 picograms per mil in the serum, 11.4 in the CSF. So this is about 2 and a bit% gets from blood into brain. We are doing the CSF analyses currently, and hopefully by the end of this, in the next couple of weeks, we will know how much gets into the CSF in this larger cohort of people. And if some people, there's a high level of brain penetration, then it will be very interesting if those are the people who have a clinical response. Whereas if other people have no brain penetration, well, of course, there's little chance of them getting any clinical response. If the drug doesn't get into the brain in anybody, then that closes the chapter on this drug being useful in Parkinson's disease. The other thing, of course, as well as exenatide levels, is looking at these targets. You know, we've speculated all along, and we had some data from the last trial, that the way exenatide works is on the insulin signaling pathway, and we can measure the insulin signaling pathway in the blood using what we call exosomes. So I won't go into the details of that, but in the last trial we found that there were some changes, and so we're going to repeat this in the current trial to see if these changes still happen but are irrelevant to the clinical scores, or if they happen in some people and there's a relationship between these changes in the biofluids and what happens in reality. So we might not be able to pick out clinically who's done better and who hasn't, but if we can biochemically, then it may be a way of salvaging something positive out of this. So we've had our first analysis completed in July. We met our steering committee to discuss what to do next at the end of that month. And of course, there was a lot of uncertainty in terms of, well, you need to look at subgroups, you need to get levels of drug tested in spinal fluid and blood. We were under embargo. We couldn't share their data with anybody until AstraZeneca gave us the green light, because had these been positive, then AstraZeneca may have wanted to exploit this. And so we signed a contract with them at the start that we wouldn't share it. So we were given permission to share the results on the 11th September. And we notified participants on the 14th of September. And we had a lot of discussions about, with colleagues around the world, how important it is to share the data with patients first. And I have a deadline at the end of the year to have a formal draft report ready for NIHR, who funded this trial. This is really important. At the start of the trial, we knew how important it was to communicate with participants and keep people up to date with where the trial is in terms of recruitment, retention, how long till we finish. COVID-19 didn't help matters because we had some additional delays, but we sent out thank you cards, we sent out 2 newsletters. We realised retrospectively that we should have done better. We had to get approval from the ethics committee for all of this, and we should have dictated at the start that with our ethics committee that we can send whichever correspondence to whichever patient, whichever time, as we see fit, and that's of course what we'll do next time. But the delay between February and our trial results in July and sharing the results with participants in October led to quite a lot of upset in the participants that were recruited. And in a sense, I absolutely recognise the importance of making sure that that doesn't happen, because people have given up 2 years of their time coming for all these visits, having lumbar punctures, DAT scan, everything, to then be sat in limbo saying, well, hang on, what are the results? We know you've finished. Tell us the data. This is vitally important, and we will, and we know how now how we will do better next time. So there are my acknowledgements and funders. Thank you for your attention.
So thank you very much, Tom. I'm going to ask Catherine and Rick, who are both participants in the study, to join us on stage now for a Q&A. We will have mics moving around the room for questions from the audience. But before we do, we did have a couple of scripted questions just while people are organising themselves. And I thought I'd start firstly just with Rick, if you don't mind. When you were considering, because the theme of today is getting involved in research, when you were thinking of getting involved in this particular study, what was the mindset?
Very simply for me, this was based on some of the earlier results from the phase 2 trial. As we saw, the phase 2 results set out some promising suggestions that this was a drug that could do something for Parkinson's. So that was very much front and centre to my thinking.
I want to probe a little bit
Please do.
here, though, because there's the results, but then there's the sitting in front of the doctor and signing the dotted line.
Yeah, I suppose for me, you know, as soon as I was diagnosed with Parkinson's, I was Googling researchers to try and figure out how the hell I played a part in finding a cure for Parkinson's. As one of the gentlemen over here said earlier, you have to be proactive about this, and that was very much my focus. I was young when I was diagnosed, 46, so I kind of felt I had a real vested interest in doing all that I could to try and find a cure. So I had no qualms about the process of participation. It was just basically trying to figure out which one was the most probable to deliver something meaningful. And as I said, because of the phase 2 results, I plumbed for Exenatide. That was a shame, wasn't it?
Kathy, the same question to you. What was the mindset going in?
Yeah, it's very similar, actually. I'd just been diagnosed 4 months before, and it was a mixture of altruism and desperation, I think. I just wanted to try something. I had to do something. I couldn't sit and wait around for other people to do it. And I was 42 when I was diagnosed with 2 young children, and I just felt I needed to do something. So it wasn't a difficult decision. There was no weighing up. The only thing I did need to think carefully about was, could I commit to it for 2 years? I work 4 days a week, I've got young children, and I decided, yes, I could commit to it, and I didn't hesitate to sign up.
And Rick, back to you. When you found out the results, what was the thinking? How did you feel?
I was gutted, quite frankly. I was on the placebo, and that was less of a disappointment, significantly less of a disappointment, because clearly when you go into a trial like this, you have to go with your eyes open that you may be on the placebo. So that was okay. But I have to say, when I saw Tom's presentation a few weeks ago, for a week afterwards, I was frankly really deflated. It felt like an unexpected outcome, really. I think, and perhaps there's an important lesson in that. We need to be perhaps slightly more critical with our thinking. But yeah, fundamentally, overall, I was absolutely gutted by the results.
Would this experience change your thought process in terms of going into another trial?
Absolutely not. I mean, the 200 people committed 2 years of their life to taking part in this trial, and 200 people are going to have to do the same again if we have any desire to try and find a cure for Parkinson's. So I feel I'm more aware of what's expected for a trial. Cycling to Oxford Hospital in the snow, for example, I didn't expect that at the start of the trial. But absolutely not dampen my enthusiasm. At the moment, as things stand, the only way that we're going to find a cure for Parkinson's is by following a large-scale double-blind trial. If we don't step up and take part, it's never going to happen.
Kathy, same question for you.
And it's a similar answer. I felt, on hearing the results, for the first time since diagnosis, I felt hopeless. And that feeling stayed with me for several weeks. It was very difficult because I think it shouldn't be underestimated the extent to which you buy into this emotionally. And I think hopes were high for Exenatide among the whole community, and everyone was excited and talking about it. And it was very hard, and I've had time to come to terms with it now, but it was like the piece of hope you'd carried around in your pocket for 3.5 years, actually, since my diagnosis, had just been extinguished. And I feel better about it now. I've had time to reflect, and I think there's a lot we can learn from this going forward, so I do feel better, but it was very difficult at the time.
And would you reconsider going into another trial?
I wouldn't hesitate. I'm actively looking to get involved in another trial.
Tom, we had some scripted questions for you, but I'm going to go off the script here. Before I took on this job, I had little comprehension for the toll that these kind of projects take on the investigators that coordinate them. It's a very, very long process, and we are now here at the end of that process. And what Catherine was saying about the buy-in, you're a human being. You can't not sort of be sitting there thinking, I'm seeing positive effects here. Maybe there's something. Can I ask you how you, as an investigator, felt when you saw the results? Where were you when you were given the result?
So yeah, I was very surprised, and the reason being, not only had we had 2 trials that had reported positive results, there were so many people who I see in clinic who finished the trial and said, I don't know if I was on active drug or placebo, but I want to carry on with it because I've been good for the last 2 years, and having stopped the injections, the wheels are falling off. So I want to go back on that drug. And that to me just sounded so, okay, that's pretty objective. Something is happening. So when our statistician, said we need to go through these data, she was a nervous wreck because she knew how convinced I was that we'll be getting the champagne out and celebrating the positive news. So it was a huge shock to hear that, the primary outcome was negative, and so all the secondary outcomes. And no matter how we looked at the data, in more and more detail, we couldn't find the positive results that everyone was anticipating. So, you feel different degrees of disappointment. Of course, there's disappointment on behalf of everybody with Parkinson's disease who have been involved in the trial and who have got their hopes, it's very nicely articulated. It is hope that kills you, isn't it? But it hopes that drives you forward. And I think that is what has to emerge from this, is that this isn't the end of hope. It's a huge disappointment. But from this, there are the next experiments that need to be done, and so let's press on and get them done. My personal disappointment is, come to an end because, I have to be a scientist, and these are the results, and I have to make sure that we have done these as carefully as can be done. That's my responsibility. But having completed that and written up the results in a very transparent way, then we move on and we do the next experiment. And if it's something related or something different, then we justify that. So disappointed, but have to be pragmatic.
And just with regards to those next steps, can you expand on that a little bit? Is this the end of Exenatide, but what does it mean for the GLP-1 field?
So, a little bit, if we show that there's no exenatide detectable in the spinal fluid, then I think that is likely to be the end of exenatide. The thing that might breathe life back into the GLP-1 field is the semaglutide trials. There's a trial in Parkinson's, there's a trial in Alzheimer's disease, and we already believe that semaglutide doesn't get into the brain. If semaglutide has positive clinical effects in Parkinson's or Alzheimer's patients, then perhaps the drug doesn't need to get into the brain. It has some peripheral effect that indirectly improves brain cell health, or a process which is aggravating neurodegeneration that is peripheral in its origin. So I think that will be the predictable thing that can rejuvenate this field. But I think the weight of evidence, when you look at Neurally, our trial, obviously there's the exenatide trial, which is smaller, and that there is some data there. But again, they don't have CSF data, and they don't have quite as many objective outcomes. So, I want to make sure that we are as robust, thorough as we can be. And if there's no signal, then we don't invest more time and resources into pursuing that. Whereas if there is a signal, we're very objective about what that signal is and who might be appropriate for further explorations.
Okay, I'd like to open up to questions from the audience, and we have one in the... we'll go to the back row first. He had his hand up before I even started the Q&A.
Hi. Yeah, I'm a very positive person, always try and see positive in everything, and thanks for all the research you've done and for taking part in the research as well. You mentioned, you showed lots of graphs and looked at an average in terms of the effect of the drugs and the trials and everything, but you also pointed out there were positive people who were able to say they were positively impacted by the going on the trial and they weren't on the placebo. And I know the placebo effect is very powerful, but is there a way of investigating if there was something going on in that group that were on the trial that reported positive impact, whether it's worth delving deeper and another trial taking place to investigate what was going on with that group?
Yeah, so that's exactly what we want to do as the next, if hopefully not final step, but if we find that there's a group where exenatide gets into the spinal fluid, the central nervous system, and in that group it engages the target that we think is relevant to how it works, and that is the group that get benefit, whereas people where the drug doesn't get to the right place, doesn't engage the target, they don't benefit, then there's a clear way of identifying, these are the subgroups, the responders and the non-responders. It becomes a robust argument. And then the next trial would be, well, how do we pick those people out, either right at the start or immediately after they're exposed to the drug, and then we follow those people up. It's, I don't want to clutch at straws. It's an important thing that needs to be done. But all of the other things that we've already done, that we were hoping to tease out the answer, haven't been helpful. So the more things we do that fails to identify the subgroup of responders, then the more sanguine I'm being about the drug in its entirety. So, I don't want to leave this room with people saying, right, we're imminently about to find the subgroup that has helped. We will look as thoroughly as can be looked to see if there is a subgroup. And if there is, then great. But if there isn't, then that's what we have to disseminate.
We have a question in the front row.
Yes, hi. Full disclosure, I was on the exenatide trial. I was randomised to exenatide, and my primary feeling was disbelief, and still is, because I felt I had a benefit from it. I'm aware of everything we've said about the placebo effect, but yes, it was such a shock, as Katie said. Just real loss of hope for the first time in I've been diagnosed 7 years. So what I wanted to ask is, how confident are you about the compliance? Because I believe that the way that was tracked was asking participants how many of the pens they had left. So given that it was under COVID, well, I was sort of mostly under COVID, I'm just wondering how you can check that people actually had used all the doses, because 100% of participants had problems with nodules, so I'm just wondering.
Yeah. I mean, the most objective information we'll get is when we, have everybody's blood levels at the end. We can compare placebo versus active. But what we're also doing is measuring blood levels at the start, because the assay's got a bit of noise. So, anyone in the room, we measure exenatide, and there's a blip there, which might be GLP-1 itself, but it's just noise in the data. And so by measuring the levels at the start and levels at the end, we can subtract the number at the start and see what the difference is, and that's really the exenatide. And so we can see very objectively the people who are randomised to exenatide, who had good levels at the end, which is an absolutely objective measure of compliance.
We'll take a question back here, and then we'll take some online questions. Thank
Hi, full disclosure again from me. I was diagnosed 6 years ago nearly, and on diagnosis I was referred to Professor Foltynie because he was doing this research into exenatide. And I thought, yippee, my Parkinson's is going to get sorted and I'm going to get skinny all in one go. However, I injected myself with saline for 96 weeks, but I was still gutted at the results, obviously, really disappointed. Couple of things that come from that. I was at Parkon a few weeks ago in Leeds, and Professor Bloom spoke, and he was very clear that when you're doing research for Parkinson's especially, you're not doing it for you, you're doing it for future generations, because that's sadly the way it seems to work. I mean, I don't know if he knew the news about exenatide, he may have done because we heard the next day. But what it also means to us as the people with Parkinson's, that we have to step up, because we're not going to find a cure without us. We're not the people, there's not going to be a cure for Parkinson's unless people with Parkinson's step up and do these trials. So yes, I was gutted. It felt like a body blow. I think I couldn't even cry. I didn't even know what to do. But the fight has to go on. The show must go on. And thank you, Tom, and I'm sure you were gutted too. But thanks for everything. It was a really good experience, even if I was on salt water. And I got nodules.
Some questions from online.
Hi. So we have one from online. So we talk a lot about the measures that they use during the trial, and it's that UPDRS score. But has there ever been any thought into, whether just taking that score at the beginning of the trial one time is enough to know the person's sort of baseline condition? Would it be worth, and maybe this is a question for Rick and Katie as well, if, should we be taking UPDRS scores during a normal clinician visit? Is that something practical for a person with Parkinson's? Could that be used then in a clinical setting too? Do you want to go first?
Yeah, happy to. Sorry, if the question is, should the UPDRS be done repeatedly through the trial? The answer is it was.
Before the trial.
I guess I'm not quite sure how you would do that, because the trial has to have a start point at somewhere, and you have to be assessed at a point, and then obviously as the trial rolls out, you're assessed from that point onwards. I don't think I've ever been fully UPDRS tested in my consulting clinician, so I wouldn't have any information to offer a trial. It might be a good thing, but I'm not sure whether that's done as standard.
So I think I know where the question comes from. So when you participate in a trial and you come to the trial centre for the first time and you're told not to take your dopamine medications, and you're not sure who you're going to meet, where they're going to be, if there's going to be parking, if there's going to be all sorts of things, then of course it's an additional stress. And so your Parkinson's on day one can be worse than usual because of everything you've been put through. But then the second time, maybe 6 months later, you know where you're going, you know where to park, you trust the team, and so your Parkinson's is better. And so it can look like, this drug's been marvellous, because your scores are better over 6 months, but it's just that turmoil and ordeal on the first one. So doing a few scores at the start gets rid of that turbulence, that noise in the data, and so you have a more accurate baseline.
I think also we just need to bear in mind it's such a snapshot when you do that examination, and there are lots of things that can impact on that. As you said, Tom, you don't know where you're going, maybe the first time, maybe you didn't sleep well the night before. And we know now that with women, where you are in your menstrual cycle can impact on how bad your Parkinson's is on that week. So I think women should be asked about which day of the cycle they're on, because that can have quite a significant impact on the findings. But also I'd like to see more use of wearable tech to take these measurements. We're just starting to do it, but you'd wear it for a week or so, and it's much less of a snapshot. And I don't know, we should use more of that, Tom?
Yeah, absolutely. So obviously the big project that Simon mentioned is this Exenatide PD is a platform trial where we'll be testing multiple drugs against a shared placebo. So fewer people on placebo for the duration of follow-up. And we will have a screening assessment and then do a baseline assessment separately, so that first data collection is not going to contaminate someone's true baseline score later. And of course, we're going to use a patient-reported measure rather than the clinician-reported UPDRS Part 3. And en route, people will have digital wearables in a large scale, so we can see if that can be a better way of predicting earlier what happens to the patient-reported outcome down the line.
Question for the third row.
Me?
Yes, you.
Tom, you effectively had the champagne on ice, yeah? So the figures may not be telling that story, but why did you feel that was what was happening? Why did you feel so positive about it? And also the two ladies, one on stage, one on the front row, why was the positive? What was happening for you that you thought this was working?
Should I go first? I was on the real drug, and I was baffled all the time I was on the trial. I had no idea if I was on the real drug or the placebo. I was hoping and waiting to feel sick. I was hoping I might lose weight, or I don't need to, because I thought they're the key side effects. Maybe I'm on the real drug. But nothing happened. I didn't feel any sickness, had no other side effects. So I began to think I was on the placebo, but I had a really steady 2 years. My medication didn't change at all. My motor symptoms hardly changed. I could feel myself slightly progressing, but nothing much really. And then I had my last injection in June 2023, and I felt fine for several months afterwards. It was only about this time last year I began to develop insomnia. And early this year, my gait got worse, my manual dexterity got worse. Everything felt suddenly to be getting worse, and I couldn't understand why. And I developed some other non-motor symptoms for the first time. And then in September, I was told I'd been taking the real drug, and it was just quite hard, actually, to hear that, because I'd been taking a treatment that had benefited me that had since been stopped. So yeah, that was quite difficult.
Yes, it's similar, really.
Yes. Yeah, go on.
Can we get the mic?
Yes.
Thanks. Yeah, similar for me. I was one of the first 8 people recruited, so I started in February 2020 and went into lockdown. But I basically didn't have much progression over the 2 years, and even for a while afterwards, really. My last dose of Exenatide was in December 2021, and for most of 2022, I was still not really progressing at the rate that I would have expected to be. Although I know Parkinson's is so individual, it's really, sliding doors. You don't know how bad you would have been. When I was told I was randomised to Exenatide in September, I wasn't surprised at all, because about a year after I stopped being actively participating in the trial, my symptoms just fell off a cliff. I mean, that's how drastic it was. I went from being really functional to having all sorts of things that you hear other people having. And it was quite striking. So yeah, when I heard that I'd been randomised to Exenatide in September, I wasn't at all surprised because of that. So I still feel a bit disbelieving about the results for that reason.
Can I just chip in, because I was on the placebo, and a very similar story. I didn't progress through the 2 years. I haven't increased my medication. I still haven't. And so for every story like this, there's a counter one where, I'm either benefiting from a placebo effect, or I'm just not particularly progressing very fast. And this is all the noise that obviously Tom's tried to unpick with all the data.
I'm just seeing a subgroup here of young onset Parkinson's women that seem to have done quite well on the trial and were actually getting the real stuff. There's a potential subgroup maybe. And you're looking at hormones. GLP-1 is a hormone. Dopamine, which we're shoving in our body the whole time, is a hormone. They've got estrogen going on. There's 3 ingredients. See what happens with those. Come back to me.
I'll come back to you. Exactly that. If we find something that stands up to scrutiny, then we shout it from the rooftops.
We'll go Harrison Ford, John, and then James Dean.
Hi, question for Tom. So I just wanted to get a sense of the numbers. We've got a phase 2 trial which showed apparently a response in part 3 UPDRS and a phase 3 trial that showed no response compared to placebo. So looking at the sort of p-values and so on, what's the probability that the phase 2 trial was wrong? And what's the probability that the phase 3 trial was wrong? Because one of them has to be wrong, I assume.
I mean, it's you know, we wondered if there's something different about the patients. You know, so both could be correct. That in one trial there was this group of patients who may have more insulin resistance. In the second trial, we had fewer of those patients, and so you know there may have been some people who responded, but that signal was drowned by all the non-responders. So it is possible that both are correct. It's also possible that there was a bigger placebo effect in the first trial, or more observer bias in the first trial. You know, we tried in both to make sure that the people who are rating the UPDRS Part 3 were kept separate from the reports of weight loss, nausea, the things that you see with exenatide. But, you know, patients, even if they're asked, you know, don't tell this person if you've got weight loss. If they say, I certainly won't, but my clothes are fitting so much better these days. You know, these things do leak out despite best intentions. And so we can't exclude observer bias being part of it. We can't exclude placebo effects and different levels of observer bias and placebo effects between the two trials. So this is where, you know, I want to be as scientifically robust as possible and say, well, okay, let's look to see if there's a difference across trials and within trials about CSF penetration and target engagement, because that gets rid of all of the clinical data, all of the observer bias, all of the placebo effects, and just, you know, what happened on blood tests looking at exosomes and CSF analyses. And if there's no difference between exenatide and placebo on those, you know, there's no reason to pursue. And you know, I don't mind at all say, well, okay, well, let's look in the women, let's look in the short people, the tall people, the Harrison Ford lookalikes. You know, but at some point we've got to say, look, you know, if it only helps one person, then this is not going to go anywhere.
But it seems like the trials were very well designed. So just on face value, I mean, this is the nature of medical science, that sometimes the trial gives a wrong result, just statistically. So just wants to get a sense of how unlikely it is, if that makes sense.
Yeah, so because it was negative on all of the outcomes, you know, there's consistency across all of the measures, then the likelihood that we've just missed it by chance, it becomes less and less.
Front row, John, and then Ian Botham.
Well, that's certainly not me, I know that. Well, one quick comment and then a wider question. I'm diabetic and have Parkinson's for a good many years now. And recently was prescribed dulaglutide, another one in this group. Now, that's an injection, a once-a-week injection. Now, obviously, I knew I was taking dulaglutide. I don't think even my GP would want to play games and give me saline. This is not part of a clinical trial, I should add, but immediately after taking it, whether it's a placebo effect or not, for about 2 days, my motor scores, to my own satisfaction, improved. So that was just the comment. The other part I wanted to ask is, and essentially you partly answered it, Tom, is whether or not there is an accidental unblinding of the study. There have been few studies, possibly GGNF as well, but as high profile as this particular one, the exenatide one. Is it possible, do you think that the unblinding may have occurred? There are discussion forums, and as you say, the people are always looking to say, I think I'm on such and such because, you know, I get stinging at injection sites or whatever. And obviously, the longer the trial goes on, the more likely that is. Yes, that's actually turned more into a comment, but...
Yeah, well, I mean, just to respond to your comments, people with diabetes and Parkinson's tend to have a steeper trajectory than people who just have Parkinson's. Now, whether the GLP-1 receptor agonists uniquely help people who have diabetes and Parkinson's, as opposed to the group who just have Parkinson's, we deliberately excluded people with diabetes from the trial, knowing that these drugs help diabetes control, and therefore any signal would just be attributed, well, you've just helped their diabetes. That's all you've done. You've done nothing for their Parkinson's, you've just helped their diabetes. But it might be that in people who have diabetes, these drugs do mitigate the worsening due to diabetes, or may do something to a unique mechanism that only occurs in people with diabetes and Parkinson's. Dulaglutide isn't thought to get into the brain, but again, this question is, does it have to get into the brain even? And when we have the semaglutide results, that will be really, really important. And your other comment, my working memory's failed.
Just about whether or not the study is accidentally unblinded.
Yeah, well, absolutely. Looking at the weight loss in the second year in the placebo group would be consistent with that. People are talking about, well, exenatide causes weight loss. So if you haven't lost weight, then you must be on the placebo. Of course, is the biggest driver for everyone on placebo to start losing weight. It's just desire. I don't want to be wasting my time here. That's better. I'll go on the treadmill and now I'll be on the active drug.
I'm trying to control the number of sandwiches they eat in that context.
Take Sachin Tendulkar in the front row here, and then we'll have another question online.
No, my question was answered by Rick. I was concerned about how he responded to placebo and why. Yeah, you sort of answered my question, but you told me during the trial you were doing really, really well, and you were convinced you were on exenatide.
Absolutely convinced. Yeah.
And it's turned out you're on placebo.
Yeah.
So a lot of clinical trials of disease-modifying drugs also have a lot of patients who have a placebo response. So here's a unique opportunity for you to say why that was happening for you. Did you secretly get on the treadmill? Did you eat less of John Stanford's sandwiches?
I think I actually put weight on because, of course, it was lockdown, so we were all slightly more static than we would otherwise have been. I think I am progressing very, very slowly, just as a matter of course. I haven't changed my levodopa in about 4 years. So I think, again, there are always going to be anomalies of the people who are making up every trial. And so all this extra noise, I think, adds to the complexity. But I was absolutely 100% convinced. I was convinced so much that I convinced my neurologist to prescribe me exenatide once I finished the trial. And of course, then I started taking the exenatide and I thought, oh, I clearly wasn't on exenatide on the trial because the injection points were different and I did start to lose weight. And so perversely, I got some of the benefits of the exenatide, but not during the trial.
Thank you, and I don't suppose you've ever been asked a question by Sachin Tendulkar before.
No, I don't think I will be again either. But...
Question from online?
So we've got a couple of questions about DAT scans, and I'll ask to begin this question by defining what a DAT scan is, but were those conducted as a part of the trial, and how accurate are they as a measure of disease progression when looking at the beginning and end?
So DAT SPECT is a way of looking at the number of dopamine terminals. So DAT scan is what you inject into a vein. It circulates around the bloodstream. And then 3 hours later, the patient who's had the injection can go into a scanner and it takes a picture of where the DAT scan is stuck to. And it sticks to the presynaptic dopamine terminals. So it's a way of measuring how many dopamine cells there still are. And in Parkinson's disease, there tends to be a particular pattern of dopamine terminal cell loss. So it starts at the back of the basal ganglia and then gradually goes forwards, and it tends to be asymmetrical. So you can confirm a diagnosis of dopaminergic loss by using this DAT SPECT or DAT scan imaging. Now you can measure how severe it is, and you can get a number, and then you can repeat that measure after an interval and see if it's changed. Now, that's not routinely done, but it can be done as part of a research exercise, and then you can get a quantification of, what's changed over time. It doesn't correlate very well with UPDRS scores. I mean, if you follow people for 4 years, then there starts to be a relationship between UPDRS Part 3 progression and DAT scan change. But over 1 and 2 years, the correlation is really flimsy. We did DAT scan in a subgroup of people at the start and at the end of 2 years. And the reason for doing that was because, one, we were expecting to have a clinical benefit, and we were expecting to get the champagne out of the freezer. Everyone will be delighted with this, but we're expecting to be criticised that you're just helping symptoms, a bit like people get with levodopa or the dopamine agonists, and this isn't really doing anything to the disease progression. You're just hiding the symptoms, the same as existing drugs. And so we're hoping that the DAT scans would show that there was less decline over the 2 years in the exenatide group than the placebo group. And irrespective of the clinical scores and a relationship between the clinical scores and the DAT scan, an advantage, a difference between exenatide and placebo would be really strong evidence that this is more than just hiding the symptoms. We analysed the DAT scans, and there was no difference between exenatide and placebo, taking the whole group. And so, again, it's consistent with all of the clinical data, but we know that there isn't a strong relationship between UPDRS scores over 2 years and DAT scan.
Lovely lady in the front row, please.
I was wondering, slightly odd question, I suppose, whether, given we've been hearing how devastated people were when they heard it hadn't worked, and given the strength of the placebo in all these trials, I wonder how strong the ethical argument is for behaving unethically in this case, and saying that it has been working. For all these people, would that have made a huge difference at the end of it? I realise you can't do that in the long run, but in the short run, is there a temptation?
Well, I mean, the temptation is to give people placebo, because it works.
Yeah.
And it really does work. And if you could bottle it, which you can, but if you can ethically dispense it and maintain people on it, then it seems to work beautifully.
Is there some means of doing that in the longer term?
Yeah, well, I mean, you can label it hope.
So I've got 2 hands up in the back row there, and I'll come to Alison. Oh, well, let's start and make our way, and they can pass it down through the crowd.
Yeah. I was just going to ask the same question, but in a different way, of the very helpful participants of the trial, because psychology is interesting, because you didn't take, you were on the placebo, then you went on to exenatide, and I was just wondering whether you were tempted to carry on with that. And with the lady in the middle, you felt that exenatide worked for you. What's stopping you from going on exenatide and carrying on externally from the trial?
I've tried and I can't get it prescribed. And that's been really hard, actually. I've asked for it several times.
But, yeah.
So sorry. I think it really depends by consultant. Some are more willing. I got my, I had a 3-monthly or 3 times renewing prescription. I haven't actually taken another prescription since the results came out, which is kind of like counterproductive, because I did lose weight. I did feel better about myself for being thinner and being in the gym more. But having heard the evidence, I can't take the exenatide thinking it's helping my Parkinson's. Potentially it's helping me in a broader perspective, because obviously GLP-1s are in the news an awful lot at the moment. But, as far as I know, that's nothing to do with my Parkinson's. It's just making me slimmer and fitting into my gym wear slightly better.
I can't say if it worked in terms of being a placebo for me, or if it worked because it worked, but I just know that I felt okay. I felt stable.
Kevin Costner.
I thought you'd find something for me. This has clearly been very disappointing for a lot of people. And I'd like to ask particularly Tom and Simon, now that the favourite has fallen at the last fence, which horse do we now put our money or our hope on? I'd like to ask the bookies.
Age before beauty, Tom.
So it depends a little bit on some of the biases we all have. We're setting up a platform trial, and we've been through all of the drugs that are available for inclusion in that trial, and the front runners are tirazacin, telmisartan, and UDCA, based on all of the laboratory data and all of the clinical work that's been done. You can say, well, why not Ambroxol? Ambroxol is, quite rightly the subject of a phase 3 trial, and there's good evidence of target engagement in people with Parkinson's disease. And so it's really important to see if that gives a positive result. And I'd absolutely subscribe to that. And you could also say, well, what about all of the commercial compounds? Drugs that, bust alpha-synuclein to pieces, such as Anli-138B, or the immunotherapies. There's the Padova trial that's using an alpha-synuclein antibody. The earlier phase 2 is a bit dubious, but they've got a reasonable rationale for taking this into a larger group. And of course, all the inflammatory approaches that we've heard, the DAPA PD trial in Cambridge, that there's a good rationale for that. And there's LRRK2 inhibitors that can perhaps be uniquely helpful for people who have LRRK2 as the cause of their Parkinson's disease, or may be helpful for the broader population. And it does raise the subject, perhaps we should be a bit more precision-based, and people who have an inflammatory cause of Parkinson's should be identified and in the inflammatory trials, and people who have a LRRK2 should be in the LRRK2 trials, people who have definite alpha-synuclein aggregation should be in the alpha-synuclein trial. And so we should be a little bit more precise rather than taking all comers. And that kind of thinking needs to be incorporated into the inclusion criteria and the planned analyses of trials. But I'd say there are still plenty of horses in the race, and I certainly don't want to extinguish people's hope because of the Exenatide results. I want to reassure people that we've really done things as thoroughly as can be done, and we're not being incorrect in the reports that we're describing.
I just wonder, I can't help but feel whether it might be too simplistic to suggest that the reason that is it possible that the outcome measures that we measure are not accurate. We just simply don't have an outcome measure that's accurate, a test that's accurate enough to measure how our symptoms are progressing if we don't know how quickly they would have progressed anyway. Everybody's alarms going up. Is that a possibility that we just don't have an outcome measure that's sensitive enough?
Yeah, I think that's exactly right. Our current outcome measures are poor. I suppose over 2 years, you'd expect if the drug was doing something useful, there would be daylight starting to emerge between either a clinician-reported or a patient-reported measure about motor symptoms, or their cognition, or their depression, or something. But from the activity, which is measured, absolute details about how much walking someone's doing over the course of a whole week, that doesn't change, between the two groups. And so I suppose, the next step would be, well, okay, let's get rid of all of the data we've looked at subgroups for, and instead focus on the activity and say, well, let's look at subgroups in the activity. Is there a signal there using a measure that's perhaps a bit more sensitive? And, I'll say to Cameron, we should not miss that opportunity, even though there's only 100 people, not 200, that participated in that part. But if there's a signal there and it emerges, then it generates a new hypothesis. So okay, we need to now confirm this in a defined trial.
We're going to take we're at time, so we're going to take 2 more questions. The young man in the back row and the young lady who's had her hand up all this time in the front row.
Obviously, the idea of GLP-1 agonists is improving glycemic control, and potentially that is a mechanism through it which improves Parkinson's. But have you actually tried to separate out those people who actually did improve their glycemic control from those who didn't improve their glycemic control? So that would be a factor, because obviously some people take a GLP-1 agonist and the glycemic control remains the same. So have you tried to disaggregate that?
Yeah. So obviously we excluded anybody with diabetes from the trial, but there are people you can measure insulin resistance, and so we collected HbA1cs, glucose and insulin levels, C-peptide levels at the start, and so we can look at peripheral insulin resistance. We haven't seen any difference in between exenatide and placebo on people who, according to their baseline levels of insulin resistance, or for that matter, we haven't seen a major change in insulin resistance, which worries me a little bit about target engagement. So we haven't seen that there's a big change over the course of the 2 years in the exenatide treated group.
In itself, the HbA1c is your key thing, because if that's not shifting, it's not having an effect, and therefore wouldn't have the knock-on effect. So it's not that, it's that you're failing to improve glycemic control.
Well, it's two things. Firstly, you can say, does it, if it was to help Parkinson's, is it through a peripheral sugar control, which a priori we didn't think that was a mechanism. We thought it was central insulin resistance as opposed to peripheral. That's one thing. But secondly, yes, you're right. So there's evidence from the diabetes trial that this drug improves HbA1c in diabetic patients, but we didn't have any diabetic patients. But of course, there's borderline glucose intolerant people, and we didn't see, or maybe we just didn't have the numbers to see a significant shift in that borderline insulin resistance, which is, as you say, disappointing, that you'd expect to see at least that peripheral target effect to have been engaged.
Just picking up on the question about outcome measures, I'm just wondering whether, because Parkinson's is such a heterogeneous condition, do we need to change the way we measure it completely? Like not, we're looking at a blanket cohort and we're applying the same measure to all of them, and they all start in different places with different symptoms and different progression. I just wonder, it feels like an impossible question really, but...
Yeah, so across the pond in North America, they're saying it's too difficult to do this in people with Parkinson's disease. We're going to look at people who are at risk of Parkinson's disease, and so we take people with lack of sense of smell, or who have a genetic association with Parkinson's disease but haven't got any symptoms. And of course, they're looking at the seed amplification assay as a way of stratifying, well, this person is now at risk of getting Parkinson's because we can see the process starting up. Now, of course, that raises challenges, that the duration of follow-up needed in order to find if your drug stops people preventing Parkinson's is going to be longer, it's going to be more costly. My perspective is, when someone turns up in clinic saying, well, I've got a tremor, or I've lost my arm swing, or I've got a frozen shoulder, that is a disaster if at that point we say, well, it's too late for you. Surely it's not too late, to intervene and slow down Parkinson's progression when they've got, decades of life left with Parkinson's disease. If that's too late for a disease-modifying therapy, then, I'll eat my hat.
Michael, I'm going to give you the last audience question.
Thank you.
And I'm just going to say that we've had questions online. We're going to provide written answers for those in the follow-up to this meeting.
Question for you, Simon. Does this kill off a trial for Exenatide? A phase 3, I mean.
I thought I dodged the do you have any favourites question. No, but look, I think
You can dodge that because it's down to Sanofi, and Sanofi are not interested.
Yeah, that's a good answer. I was intrigued by Tom's answer before when I asked about the future of the GLP-1 field. I still think there's a lot of work to be done in terms of brain penetrance or need of brain penetrance. And after learning the results of the trial, I went and looked at the history of the development of L-DOPA, and it was a real roller coaster all the way through. There were 3 pilot studies, gave fantastic results. Then there was a mixed bag, including 2 double-blind, randomized control studies that showed absolutely no difference. And it was tweaks here and tweaks there in that developmental process, and the addition of another drug, so a combination therapy, that gave us the levodopa-carbidopa treatment that we have now. That's the gold standard. And it's not a start point and an end point with research. It is a continual process, a continual evolution. We're going to make mistakes. We're going to have setbacks along the way. But and that's part of the importance of being prepared to be involved in research, is that somebody said before, we're doing this for the future generation. So I don't think this is the end of the GLP-1 field. I think it's simply one of many steps going forward. I had something else to say, but I can't remember what it was now. I did follow through with what the folks online wanted me to say. I remembered to say that. I'm going to give Helen the last word, but what I will do is I'm going to ask one more question of Rick and Kathy before. One of the nice parts of being involved in research is the opportunity to actually feed back to the scientists. So my question for you is there anything, having gone through the process, is there anything that we could change or do better, or that you'd like to see different in future trials, other than having a pandemic in the middle of them?
God, that's a huge question to try and tie everything up with a bow.
30 seconds. 30 seconds.
I think. Sorry, do you want to go?
No, after you.
I'm going to waste precious seconds. I think from my perspective, it was very well organised. I had all the information I needed to make an informed decision. The patient information leaflet was good. Everything was good. The site staff in Oxford, where I went, were excellent. The only thing that was missing, I think, is some sort of I don't know what to call it, sort of aftercare. When you take part in a trial, it's quite a big commitment. You go through it for a long time. And I felt like at the end of the trial, there's nothing there. I didn't know anyone else who took part in Exenatide. Never met anyone else. So actually, I was dealing with the disappointment all on my own. And I think I wouldn't want to put anything expensive in place that detracts attention from the research itself. But maybe something low cost that you could just put people in touch with one another, ask participants they want to share their contact details with each other, something there so they've got someone to talk to, I think would be really valuable, because I think going forwards we need to get more people involved in research. We need to look after our participants.
I still don't have a very good answer, but I suppose for me, the experience of participation was on the whole very positive, despite the outcome, despite the fact I was on the placebo. I'm glad to have taken part, and I'm sure I will be again in the future. I think the key reflection for me is that it's only going to work if the same level of commitment is shown by the research community and the patient community. That's the most important thing for me.
Wonderful. I'd like to thank the panelists for their time today, and also all of you for coming today. And I'm going to give the last word to Helen. Thank you very much, folks.
And I also wanted to say a huge thank you to you all three as panelists. Tom, thank you for a very clear presentation. I think the entire study team need commending. I think you led a trial brilliantly, but most importantly, the participants who took part in this study really need to be celebrated. That was a very big journey, and it's not the result any of us hoped for. And Casey, you said the critical word there, which is hope. I'm going to just reflect on something that Tom Isaac said, which is for him, the best medicine of all was hope. And we do travel in hope. We carry on investing in research because we do hope to find a cure. And with your help, we will get there. If you will put your hand up, take part, stay involved, keep hearing the updates. But thank you to all our presenters. Thank you to all of you for being here. Thank you to Simon for leading that conversation so brilliantly. But really, thank you all very, very much indeed.